Okay, so this is your DBMS and SQL bootcamp. So let's start. Let's start with basics of DBMS. So whenever you appear for DBMS interview, the basics thing you should know, like what is DBMS, why we are actually learning this, why it's so, what's the advantages of DBMS, right? So let's first begin with what is even data? Like why is even data important? What do you think is a data? What do you all think is a data? If I would say the efficiency of any company or business, it depends upon the data it has. I mean, user data, data about how people are, how people are interacting. So data is of very important. That information is very important and relevant for any company to take their business decisions to grow. So data is of prime importance and it acts as a core for the company's functionalities. Now the thing is, okay, the data is, we have enormous amount of data, but how can we arrange the data? To arrange data, you need some kind of a system, right? What can be those systems? Yes, data is some raw information, any just piece of information, right? Okay, so how can you arrange the data? To arrange the data, we need some kind of system. One basic system, if I can say, is let's arrange the data in files now. Let's arrange the data in files. Let's say we are developing a data for a university, and I can have something about, let's say, hmm, so I can have something about a students table. I can have a students file, students.txt. Then I can have a, let's say for employees, for organization, I have an employees file. So employees.txt file, right? So that's a very fine way to store the data, but that is not the, the good way to or efficient way to store the data. It actually depends upon the type of data you have. So that is where the concept of database management system come into picture. How will you even store the data? What optimization you will do? You just don't need to, store the data, just pour the data. No, you have to use the data, right? If you don't manage your, let's say, your wardrobe, you don't manage your wardrobe, you just keep on dumping your clothes like that because you need to store that. But no, you don't need to actually store, you need to fetch the clothes as well. Every day you need to find the clothes. So if you just dump your clothes as it is, so it will be very difficult to you to even find a particular piece of cloth, right? So you need to arrange it in proper shelves. Likewise, there are two important decisions that you need to do. The very first, storing the data. Next is querying over the data, right? Okay. So what is a DBMS? A DBMS is, okay. A DBMS is a software system that allows us to store the data and query over the data along with providing a lot of other functionalities. Okay? A DBMS is a software that allows us to store the data, query the data, along with other functionalities as well. For example, what are the other functionalities DBMS provides us? The advantages of DBMS. First is security constraints, right? Concurrency, how multiple users are accessing the database at the same time, right? There are million of people accessing the same database at the same time. How this is possible? Then backup facility, of course, backup should be there. Then security. DBMS is highly secure. The data is first encrypted, then it's stored. Then maintaining consistency of data, right? Then reducing redundancy, repetitiveness of code. Okay. Now the thing is, okay, we learned what is DBMS, but how can we structure our DBMS? Of course, the very first or traditional way of storing the data is files. But that's not the most efficient way to store the data, right? Can you tell me, okay, let's say one All of you, let's write one con of storing the data in file system. Just one con. What do you think? Why do you think storing storing the data in files is not very efficient? What do you think? Okay, if I store the data in files, if let's say you give your file to somebody, they have the access of the file, they can do any manipulations now. So there is no security, right? So there is no concurrency in files. If one person is accessing the file at one time, no other person is allowed to even access the file, right? No backup facilities or backup you can take. Consistency of data, no consistency at all. Repetitiveness of code, right? So these are some of the cons of file system. That's why we have shifted to DBMS, the database management system. Now, okay, so you want to store the data. You want to store the data about something, right? Yes, data redundancy cannot be avoided. Yes. Okay. So now the thing is, you want to store the data about something, right? Let's say for an organization, you want to store the data for students, for employees. Yeah. And for each and every student, you are storing something about it, right? So these things are actually known as entities. So what are entities? Entities are nothing but about what or whom are you storing the data for. So for an organization, you are storing the data for students, for employees, for the faculties. Similarly, there are attributes, there are fields. Like what data about entities you are storing. Okay, you are storing the data about student. But for student, you are storing their name, their ID, right? The date they have got the admission. So all this data about entities you are also storing. That is called attributes. Attributes of the entities. Then let's say there are two entities, college entity and student entity. Now you want to store the relationship between them. Okay, student took the admission in college at this date. So this is actually the relation between the two entities, right? There is no there are separate entities are there. No, there's actually a relationship between entities, right? So the third thing is relationship between different entities, right? So a database that can store the data in the form of entities and it can have some relations between them. They are called relational database management systems, RDBMS. Okay. Another important thing that can be asked, what is RDBMS? Why we are using RDBMS right now? Why it is so prevalent? Why we are not storing the data in traditional file systems? So you will tell all the drawbacks of file systems. What is the definition of RDBMS? What are the advantages of RDBMS over file systems? Okay. Okay. So some of the popular examples can be MySQL, PostgreSQL, right? Now, before going on to the SQL part, let's answer this. Suppose you are given design a schema for scalar. Okay. In scalar, you have their users, you have students, you have batches, right? So you have to design a schema. Now, what do you mean by schema? What do you mean by schema? Schema is the blueprint of your database. Like in your database, what are all the tables you will be having? You will be having a students table, user table, batches table. Like what are all the tables you will be having? And inside the tables, what are all the primary key will be there, foreign keys, unique keys, what are the different keys will be there? How are you arranging the data? So that all the definition of data, the blueprint of data is your schema. Okay. Now, how can you design a schema? That question can be asked. This is just a simple scalar. You can be asked, for example, for a food system. a food delivery system you want to create a schema for. So for that, you have to design different tables, right? This table, it will have a food order table, a customers table, dishes table, items table, right? So you want to create different tables. Then you need to find the primary key, foreign key. So let's see this. So that is how a simple schema design look like. You will have a users table. In this users table, you will have ID, name, their phone number, email. And ID is the primary key. What is the primary key of the table? What is the primary key of a table? Primary key is the unique column, the column that uniquely identifies your table, right? Here ID uniquely identifies your users table. So ID can be the primary key of my table. Unique identification key, yes. Similarly, you have a students table. Then you have batches table. In the students table, you have ID. ID is the primary key. Then you have batch ID. You have name and you have user ID as well. And what is this user ID? This user ID is actually the foreign key, right? And foreign keys, you will mark foreign key like this. This is the foreign key of ID. Okay. Then batches table. In batches table, I have the ID as the primary key. And batch ID is the foreign key of students table. Right? If any other key, let's say email can be unique, right? Every user can have unique email. So you can write unique. That means email is a unique key. Okay? And if you want a complete understanding of primary key, foreign keys, unique keys, so just check out my video. I have made a detailed video of this. And in that, I have taken a very good example. And with the example, I have explained each and every keys, okay? Now, so this can be a question, right? See, a definition-based question may not be asked. Some real-life scenarios can be asked. Just let's design a schema for that. In this, all your theories will be applied. How can you create a table? If you want to, let's say, join the tables, then primary key, foreign key. So all of your theories are covered in this question itself, right? So these type of questions you need to practice. Okay. So if you want to create a table, or let's first understand what is SQL. What is SQL? SQL is structured query language, right? That is the most popular language to query upon the data that I have stored. Now I have stored enough data. Now I want to fetch some data. I want to change some data, manipulate, insert. So all these things I can do with the help of SQL. That is the structured query language. And one more important thing, SQL is case insensitive. Case insensitive means I can write Manpreet like this. Then I can write like this as well. Okay. Both is the same. Okay. It will give the correct answer for this as well, for this. So SQL is case insensitive. Okay. Upper lowercase will not be matter. Okay. Yes. Now, how can you create a table in SQL? The syntax for that is create table. Let's create a table for the students schema. Create table. You have to write the name of table. Then inside the brackets, you will define all the columns, right? So ID column, and you have to write their data type as well. So ID is int and ID is primary key as well. So you need to write this ID, int and primary key. Similarly, batch ID, it's also int type. Name, varchar. Varchar means variable character. Name can be of 9 characters, 5 characters. So you have given it varchar. Approx it can go up to 10 characters. Then user ID int. So this is a simple syntax how you can create a table in your SQL. Now, another important query in SQL is select. Select is very important. So what's the syntax of select? Select, you have to give the name of columns which you want to select, means actually read. Read this. So read these columns. From which table? You need to define the table. Where you can write the condition. Then order by. Okay, order the table in this format. So let's say for the students table, I have their ID, their first name, their last name. For this students table, now I need to get the first name of students. Okay, what query can I write? I need to get the first name of all the students from the students table. What query can I write? Help me write the query to get the first name of all the students. Can I write like this? Select. What column I need to select? First name, right, from students. Okay, simple. Now let's say I have another student and its name is also same. Now I want to get unique names only. I want to get A, B and C. I don't want this A again. So what can I write? If I want to get unique names, the keyword for that is distinct. Yes, the keyword for that is distinct. Okay. Now the next important thing to understand here is subqueries. Subqueries or nested query. That is very important. For example, let's say you have a students table. Okay, you have a students table. Now in the students table, you want to give degree to students who are in batch 2022, who pass out in 2022. You want to get the give the degrees to them, but some students will not get degree because they fail. Okay, so we have another table here, fail student. With ID 2, 3 just fail. We don't have to give the degrees to them. So we have a fail table and we have a students table. Now, the task is you have to get the students who will get degrees. You will only have to get those students who will get degrees. Okay, that is a query you have to write. How can you do this? Can you somehow get all the students who have failed? Can you get this? Can you somehow get all the students who fail? Yes, I can simply write select ID from fail student, right? In this, from this query, I'll get all the IDs of the students who fail. Now my task is I want to get the students who will get the degree. So can I write like this? Select ID from students where batch is equal to 2022. But I don't want to give the degree to these students of these IDs, right? This ID, I don't want to give them the degree. So what can I write? Can I write like this? And not in. This is actually the keyword here, not in. Then inside this, you will write this. Select ID from fail students. So what it will do? It will first get the ID of this. It will first get the ID of these fail students. Then it will select all the ID of these students with batch 2022, but who are not there in this, inside this query. So it will return just this row. We can write like this is just to understand how subqueries work. Okay, that is very important for your interviews. You can be asked about nested queries. You are given two tables, then you want to relate something, you don't want this, you want this. So in that case, you can write subqueries. And this is just a keyword. You can write just in, you can write between keyword, exist keyword. So different type of keywords are there. Okay. Okay. Let's move ahead now. Let's understand some SQL clauses. The very first is where. Where, so we all know, it allows us to filter some rows based on certain conditions. Let's say I want to get the students who belong to batch 2022. So I can write where batch is equal to something, right? And filter on my rows. Then order by. What do you mean by order actually? Order in real life means you want some arrangement, some kind of arrangement of things, right? In the way you want to. That is the meaning of order. So I said return me the list of return me all the students, but I want order in ID as descending. That means I want to get 3, 2, 1. First 3, then 2, then 1. So you can write here ascending as well, descending as well, whatever column you want to order by, you can give the column name. Okay. Then next important, this is very important, group by is important for interviews. So group by are mostly related to your aggregate functions. Okay, what are now aggregate functions? Aggregate functions take up some set of values and they return a single value. Okay, they take up some set of values and they return a single value. Can you tell me some of the aggregate functions in SQL? So the aggregate functions are, the very first one is sum. Let's say for this column you want to find the sum of. Then you want to find count, the number of something. Then maximum. Let's say there is a students table where we have ID, name and some points. Now I want to get the maximum points. Which student got the maximum point? So I can give max. Then minimum, average. So these are all my aggregate functions. Now, yeah, similarly, you can see this example. I want to get the average of the attendance. So I can give average. Inside this, I can give name of column from students table. You want to get the sum, you can give sum here. Count, you can give count here. Right? So these are my different aggregate functions. Now let's say, this is so clear. Now let's say I want to find average attendance of every batch. Now I don't want to get the average attendance of whole table. I want to get average attendance of each batch, every batch. For example, I want to get output like this. For batch 1, average attendance is 70, 80 and 60, average is 70. For batch 2, average is 80. Right? So this I want to return now. So this you see, I don't want to do the aggregate functions in my whole table. I want to group something and then I want to perform the aggregate functions. Right? So the very first thing that I can do is group different rows of the table. I need to group these rows. Then I need to group these rows. And after that, on every group, I need to find the average. Right? This I need to do. So how can I write the query for that? Select what I need to select. I need to select the batch ID and average of the attendance. From students table, group by their batch ID. So first, how this query will work? It will group all the batches and in that group by, it will perform the average function. Okay, so this group by is also very important. Then in group by, you will be having a having clause. If you want to filter after grouping your rows, right? After that, you want, let's say, I want only those attendants who are greater than 80. So from this table, you only want this column. After grouping by, you want this row. So After grouping by, you can use a having clause. Okay. Now let's come on to joins. Joins are again very important. We have, what are joins first? What are joins? What do you mean by joins? In joins, you can be asked like why joins are important, or you are given some kind of tables, you need to join them. Let's say you are given this columns, and you need to perform a query. You need to return that. Let's say this columns are given to you. Now you see, okay, these columns are not present in one table, so you need to join multiple tables, right? So you can perform your joins based on the query you are given. You will perform inner join or outer join. In outer, we have three types of join: left, right, and full. Okay. So joins are again very important. They help in merging the two tables, right? So this is the syntax. Just you have to write the join keyword and on what condition you are joining. You have to write the condition. Okay. Now let's move ahead. Let's say indexing. Indexing is again very important. You will be asked like why we are actually indexing our table. What's the need to perform or do even indexing? Why we're actually creating index? So we are actually fetching a lot of data, right? We need to fetch the lot of data, right? But what we actually want to do, the idea is we want to get the data as fast as possible, right? We want to get the data as fast as possible. Means the query should run fast. So in that case, we can do indexing, right? So everybody, you have heard about arrays and hash maps, right? Arrays and hash maps, you all know. In arrays, if I say about arrays, if arrays, let's say, not sorted, and now you need to search an element, so it will take linear time. Similarly, in hash map, it will take probabilistic around O of 1, right? So we use indexing. Indexing also reduce our time. It helps to run our query very fast. Okay, if you want to get this query, so you will create index on that. So you can be asked like why we even need indexing. So what you will say, to fasten up our queries. Okay. So indexing is again very important. Then you have to know about the syntax, how you can create an index. So what's the syntax of creating an index? Create, you need to write index keyword, then naming should be like this. You first have to write idx underscore table name underscore name of the column for which you want to create the index on, then on which table and which column. Let's again see this with the help of an example. Create index idx underscore, let's say I want to create an index in students table and marks column. So students table, marks column, on students table, bracket, you will give the name of the column, that is marks. So you need to know about why we are actually creating index, how can we create index, okay, and when to create index. Can you tell me if can I say when you create table, then just create index? Is this correct? When you create table, then create index. This is actually not correct. Don't create index when you create the table. Create index when you have a query that needs to be speed up. If let's say you are every time you are getting something related to marks, okay, you are every time need something related to marks, this column you every time need in your query. So let's create index on this, right? So create index because of access pattern. Okay, you will see the pattern. Okay, this query is getting this column is getting repeated many times, so then let's create index on this. No, how indexes actually work is it creates a table actually. Inside the memory, it creates a table for every, let's say for this marks column. So 70, 80, 90, for every marks, a separate address is assigned to it. Let's say for address 123. Then how it actually works is, it will say, okay, this 70 marks is actually stored at address 1. So it directly goes into that address and fetch that. Right? So that's something how it uh, speed up your query. Okay? Now how actually indexes work, that you can check out my video. There will be how actually we are creating index. I actually created index on my MySQL. Okay, so you can check that video out. All the videos will get uploaded by 1 week or so. Okay. Okay. Now let's move on to string matching. Like for all the students, I want to get all the students whose name begin with M. So there is a keyword called like. If I want to match a string, a word, so there is a like keyword. Okay, in this like keyword, I have two keywords again, percentage and underscore. Percentage, it matches with any number of characters. Underscore, it matches for a single character. For example, let's solve this question only. I want to get all the students whose name begin with M. So select star from students where name like, name starts with M. So M, after that can have any number of characters, right? So after that, write percentage, right? Now, if you want, let's say I want to find all students whose name begin with any single character after that M. So you will write underscore because it matches for a single character. Just single character after that M. Okay? So this is about like keyword. Now, for normalization, you will be asked like what is normalization, of course. But again, it's not be the case like you will ask, tell me what is 2NF or 1NF, 3NF. You actually will be given a table. A denormalized table is given to you. You can be told, okay, normalize it. Or is it needed to normalize? If you find a need to normalize it, if yes, normalize it. That's something you can be asked about normalization. For duplicate marks, it actually create a list for that. Okay? It will create a list for that. Now, how actually it will be created? I can't cover indexes. If you want a separate live session on indexes, we can do that as well. But of course, you can watch my video. Okay? Index video, you will get to know all about indexes. Okay, perfect. Now, in normalization, you will be asked like, okay, you are given a denormalized table. Let's normalize this. Okay, so you will check, okay, is this following 1NF? Is this following 2NF? Is this following 3NF? Is it violates any of this? You normalize it. So these type of questions you will be asked. Okay, not a direct one. Okay, tell me what is 2NF. Okay. Now, another important thing is asset properties. This is very important. You need to know what is A, C, I, D. A stands for atomicity. C stands for consistency. I stands for isolation. D stands for durability. What are all this? Atomicity means either everything should happen or nothing should happen at all. Consistency, as the name suggests, your database should be in consistent state. The system should be consistent before the transaction starts, as well as it should be consistent after the transaction ends. Similarly, isolation. It's also suggesting us something. Okay, there are multiple transactions that are happening, right? But other transactions running in the system should not affect a given transaction. All the transactions should be isolated from each other. They should not hinder their output, right? Now, durability. Durability says after a transaction is ended, its results should persist. This is not be the case like if there's a hardware failure is there and your result is just gone. No. If the transaction is ended, your results should persist. It should be there. Now, how transactions actually handle concurrency and ensure the asset properties, it's there with the help of transaction for isolation levels. Okay, so do check out the transaction video as well, and transaction isolation levels as well. Read uncommitted, read committed, repeatable, read serializable. Okay, so you will in our video we're actually doing this, like in SQL, what happened if your isolation level is this, what happened if your isolation level is this. Okay, so that will be very interesting video, do check that out as well. Okay, so what I want to tell you in this session is key exact questions are not be asked. Give me the definition of this, give the definition of this, right? So you'll be asked some by twisting and turning the things, right? Like in normalization, you are given a table, just normalize it. So these type of questions can be asked. Some real life scenarios type of questions can be asked. Okay? So you will have to prepare likewise. About views. Okay. What do you mean by views? Okay. If I say views are kind of an abstraction. They are kind of an abstraction over real tables. They will provide a visibility to data that you want to provide. They act like a table, but there is no data stored in them. For example, let's say you are in an organization and you have prepared a table for, you have prepared two tables. Okay? Some tables, let's say some students, some employees, something. Now, another department, someone come to you and they want the complete information about both the tables. Now, you don't actually want to give them the access of the tables, right? They can manipulate your tables. They can change the rows. So what you can do is you can actually create a view over them, and you give them the view. So they are the kind of abstraction. They're actually not the real table. Now they can't change or manipulate your real tables, but then also they have the complete information, right? They can use it, they can query over your views as well. Okay, and how can you create a view? What's the syntax of view? Create, you have to write the view keyword, then name of the view. Let's say I want to create a view on students and employees. So is students comma employee. Then as you want to give, you have to write all the query. Just this syntax. It will create view on whatever query you will write, it will create view on that. Yes, a kind of a virtual table. Kind of an abstraction over your table. It's not a real table. It's kind of an abstraction over your real table. Okay, if you don't want to give your tables, complete tables, then you can create a view on that, right? Or let's say you always want to, want something from this both the tables, students table as well as employees table. So every time you are performing joins, so what you have done, you have created a view over that, so that you can now perform all your queries in that views. You don't need to join students and employees first, then you can perform your query. Okay, your view is created and you can directly perform all your queries in that views. Communication is not that great. Can you give few tips also how to prepare for SQL DBMS especially? Okay. So communication skills, you don't need to actually work on your communication skills. What you can do is you can remember, you can learn this, like let's say for views. So what you can do is you actually learn what is view, how can we create views. So just try to explain someone, or try to explain yourself how you will explain to someone. Okay, take something pen and paper and try to explain. If someone wants to learn views, how can you explain views to them? So first you will tell them the definition, then you will take an example, then you will take some real life scenarios so that they can connect well, right? So then slowly and slowly you can able to improve your communication skill with respect to DBMS and SQL as well. directly if you work on communication skills, so it will take time. Okay, so but this can improve your communication as well as your subject as well. Which are subjects we need to prepare for service based companies? Subject service based companies, to prepare well, first you need to do DSA. DSA is very important. Then your resume should stand out. You should have a good LinkedIn profile. Then you should have basic knowledge of development as well. So all this we have already covered. You can watch our video on this: resume, LinkedIn, DSA. Then you can uh, watch our JavaScript videos, and you can have we have some basic front end projects also. You can take up that. Then little bit of CS knowledge is necessary: DBMS, OSCN. Okay, when I'm facing technical interview, I know the concepts and queries, but I get nervous and forget what should I say. Okay, this will happen, but the fear will get away if you practice more. So try to do some mock interviews before actually getting on to the actual interview. Try to do some mock interviews. This will help. And of course, the trick you can also apply: try explaining to yourself. If you want to explain joints to someone, how can you do this? Then your nervousness or your thing will get solved. And try mock interviews, it's very important.